Hello, my name is Estrelita van Rensburg of Wellness EQ, and I'm delighted to speak at the first Health Bite Summit for Low Carb Melbourne. Thanks also to Tracy for giving me this opportunity to speak on my favorite topic, which is food and our metabolic health. I want to start the presentation with a graph from our book, Eat Well or Die Slowly, that looks at the prevalence of obesity, high blood pressure, and diabetes over the last 120 years. And this is US data. We can see that nothing much happened in the beginning of the 20th century. But for all three conditions, the prevalence increased shortly after the Second World War. And then if we look at the blue line for obesity, we can see that something happened around about 1980 when it increased dramatically and followed by diabetes in green as well as high blood pressure. So what happened in 1980? Well, that was the year when the US government introduced the dietary guidelines for Americans. And these guidelines advise people to restrict their fat intake, and if they did eat fat, to eat only low-fat products. But if you decrease fat, you have to increase something else. And what they increased was their carbohydrate consumption. The advice was based on the theory at the time that fat and cholesterol clogs up our arteries and causes heart disease, heart attacks, and death. But to see it a little bit more in perspective, we need to extend the timeline by another 100 years backwards. So in this graph, you can see obesity, that's the blue line, and diabetes is the orange line. Now, there wasn't a lot of data for the dotted area, but one can see the trend nevertheless. So when we look at this, we can see that something happened with obesity around about the mid-19th century, and that increased into the 20th century, and obviously that's when the dietary guidelines were introduced. So what other dietary impact did we have in the 19th century? It was sugar, because sugar consumption per person per year, as you can see here on the vertical axis, and this is UK and US data, started to increase in the 19th century, and more so after the UK abolished sugar tax. So in the 20th century, sugar consumption still went upwards with only 2 dips during the 2 world wars, as can be expected, and then progressively upwards and upwards. Now, if you closely look at the top graph of sugar consumption and you compare that to the bottom graph of obesity, it looks as if those two trends are very similar. It's also interesting to note that the guidelines actually promote an increase in sugar and carbohydrate consumption. And what's the effect of diabetes? Well, if we look at data from the UK, and this is current data, on a yearly basis, treating diabetes and its complications cost the UK government £15 billion, and that is roughly equivalent to 28 billion Australian dollars. And it's not just in the UK where there's such a massive impact on the healthcare budget, but in many countries across the globe. Now, if we want to understand more and see things in perspective, we have to go right back to the beginning of humans, so our evolutionary history, and we need to see what lessons can we learn. Now, as you can see here, the bar at the bottom, the timeline there is in millions of years, and I start with 5 million years on the right-hand side, and then we move backwards to 0, which is present day. I've also got 3 skulls at the bottom, and human history began around about 5 to 7 million years ago. That's when the human line split from, first of all, the gorilla line, and then a million years or so later from the chimpanzee line. And we can see with the skulls at the bottom, on the right-hand side, that was a very early ape-like hominin creature with a small brain capacity. And in time, over millions of years, the brain capacity increased in size until we have on the left-hand side a modern human skull. And we can see how big the difference in the brain capacity is. The question is, what drove this development of a bigger brain? Surely our diet or the diet of our evolutionary past had something to do with it. And here we can see, initially, the early hominins followed the same diet as chimps and gorillas today. They were plant eaters. They were basically vegetarian animals. And then round about 3.5 million years ago, something changed and they became carnivores. Actually, it was a gradual process. And these tree-dwelling apes in the beginning came down to the ground, and they probably started scavenging, foraging for fish, shellfish, and so on, in riverbeds as well as at the seashore. They were able to catch smaller animals. And as their brain capacity enlarged, and that was basically, scientists believe, because they ate more nutrient-dense food, they were able to use stone, make stone tools, and eventually they were able to even hunt animals and larger animals. So this graph is really just to show that for 3.5 million years during evolution, we've been meat eaters. The next change came about 11,000 years ago, when modern humans started to domesticate crops. It started in the Eastern Mediterranean area with the domestication of wheat and barley. And independently from that, corn was domesticated in Mesoamerica and rice in India and China. But if you look at the evolutionary timeline, you can't even see when crop domestication started because it's too recent an event. We have to just look and extend the last 100,000 years, and you can see that in the biggest circle. So it's a sliver of time, and only then can we start to see when crops were introduced. So on an evolutionary scale of millions of years, it's so recent that there's no way that that change in diet could have had an impact on human evolution. We're not even talking about the dietary guidelines that made changes over the last 40 years. So let's look at the macronutrient composition and how it changed during our evolution. So we're talking about the three main components that we find in food: fat, protein, and carbohydrates. So we're going to compare a plant-based diet with that of an animal-based diet. So plant-based consists mainly of protein and carbohydrates, while an animal-based diet consists of protein and fat. So plant-based was very early in hominin evolution, while the animal-based diet was for the last 3.5 million years. In the beginning, the brain size was around about 400 grams, similar to a chimp, where the average modern brain size is 1,400 grams, so a massive difference. But it wasn't only the brain that changed. We know that the gut of chimps and gorillas, they've got a very large colon, and it's needed for plant and fiber digestion to be able to digest cellulose. Now, as humans, we've lost that ability. We can't digest cellulose. So our colon is really shrunk. It's really small in comparison to the great apes, but we have a larger small intestine, and that helps us to digest fat and protein and to absorb those. Because we've got a smaller intestine, we don't have the big bellies that we see in chimps and gorillas. And that also helped us as humans to be able to walk upright. So these are just a few of the massive anatomical and physiological changes that happened to humans over millions of years. Let's look in more detail at these three macronutrients and how they changed during evolution. So in the top row, that's for modern day chimps, gorillas, as well as the early hominins. The second line for the hunter-gatherer phase, last 3.5 million years, and then we have the last 40 years. What you will notice is in the protein column that the protein intake is fairly constant at around 20%, but it's the fat and the carbohydrate content that differed markedly. So for a plant-based diet, that's the top row, carbohydrate intake is very high and fat intake is very low. You can see how that's swapped during the hunter-gatherer phase when fat became the most important macronutrient and carbohydrates almost disappeared. What we can see of the last 40 years is that fat is being reduced dramatically and the carbohydrate content is going up closer to that of a plant eater. So for the rest of the presentation, we're going to concentrate on fat and carbohydrates. And what we also need to see on this slide is that carbohydrates are not really essential for the human body to either develop or be healthy if we look at this low carbohydrate content in the middle row. So what have we learned so far? First of all, that lifestyle diseases dramatically increased since the dietary guidelines were introduced in the 1980s. And the advice was eat less fat or low fat and increase your carbohydrate consumption. And that is plant-based food as well as processed food. Over the last 5 million years, humans have evolved to eat protein and a fat-rich diet. That's an animal-based diet. So the dietary guidelines are trying to reverse the dietary composition of millions of years of evolution over a few decades. And the result is that this new diet is making us sick. For the next part of the talk, I'm going to concentrate on the science behind fat and carbohydrates so that we can understand what happens in our bodies when we eat food. So on the left-hand side, we have fat and cholesterol as a subject. On the right-hand side, carbohydrates and sugar. Now, we're all familiar with the theory of fat, cholesterol, and heart disease. Very popular theory, but in fact, it is completely wrong. There's no verifiable scientific evidence to support this theory, and we will look at that in more detail. In fact, as medical students, that was what we were taught was the correct theory of heart disease. Let's just quickly move to carbohydrates and sugar because we need to understand a little bit about the chemistry of these molecules. Sugar is nothing else than one molecule of glucose and one molecule of fructose combined. Starch, on the other hand, is just many glucose molecules holding hands. And when I'm going to talk about carbohydrates, I'm really going to talk about glucose because when these components break down in the body, it's really the body sees glucose. It doesn't see sugar or bread or potatoes or rice. Those are all starchy foods. It just sees glucose, and that's what we're going to use. So fat and cholesterol, let's start there. They are vital substances. Why? Because cholesterol is used to make bile acids. It's very important for our digestion. It's made in the liver. Secondly, 2/3 of our brain consists of cholesterol and fat. And it's very important to support all the brain functions, such as memory, learning, and many more. Cholesterol is also needed to make vitamin D. Vitamin D in combination with magnesium and calcium is critical to form strong bones and a strong skeleton. But cholesterol also is the basis for many other hormones, including all our sex hormones. Cholesterol, once again, forms part of every cell in our body's membrane, the cell membrane. And saturated fat is needed to absorb the fat-soluble vitamins from our gut. That's vitamin A, D, E, and K, who's got many, many essential functions. If we eat low-fat products, we do not have enough fat to absorb these critical vitamins adequately. What about cholesterol? We've all heard about LDL cholesterol, the so-called bad cholesterol. But what is cholesterol? What is LDL cholesterol? It's basically made in our liver, and because it's fat soluble and needs to be transported in our bloodstream to our cells, it needs a carrier, and the carrier is a protein, and that's why we call it LDL cholesterol. So it's a big fluffy particle that's transported in our body. But it can change. If we have a high sugar load in our bloodstream, the sugar can actually bind to the cholesterol and change it, and we call the process glycation. So what happens? These big fluffy particles get smaller and denser and smaller and denser, and they become small, dense particles under the influence of glucose. But glucose also damages the inside of our arteries, including our coronary arteries. So what happens then is that these small, dense particles slip inside our damaged arteries, and this forms the basis for atherosclerosis and obstruction of our coronary arteries with heart attack and death. So basically, the cholesterol is really just the bystander, the innocent bystander, and it undergoes changes. So next time when your doctor tests your cholesterol and they want to put you on statins, you can ask him or her if it is the normal cholesterol, or do you have an increased level of the small dense particles, because that's the really bad cholesterol. And there are specific tests available to test for small dense particles. Right, time to move on to carbohydrate metabolism. Now, on this graph on the left-hand side, the vertical axis, that's glucose levels in the blood. And the bar, the green bar, shows us the levels, the top and the bottom of what a normal glucose level should be. It shouldn't be above or below that level for normal function. But what happens when we eat carbohydrates, or sugar or glucose, is the blood glucose really varies. It goes high and low and high and low. And why do we see this pattern with carbohydrates? Because it stimulates the secretion of the hormone insulin from our pancreas very efficiently. And the function of insulin is to remove glucose from the bloodstream into our cells where it's used for energy. It does that very effectively. So, but it also takes too much glucose out of the bloodstream, so you get these lows. So that's very typical with carbohydrate diet. We get these hyperglycemia that we call it, and then these low dips called hypoglycemia. And what happens when we're hypoglycemic? We're hungry. So we have to eat again. So we have to eat another biscuit or another piece of cake, and so it goes. And then we're off on this roller coaster ride of high and low glucose and high insulin levels. Now, is that a problem? Let's look at insulin functions. So the first one we've demonstrated in the previous slide, it transports glucose into our cells. The second thing is it's also a fat storage hormone, and not many people know that. So any extra glucose that we eat is changed into fat. So it doesn't matter what kind of carbohydrate we eat. First of all, whatever is not used for energy in our cells goes into our liver and it's changed into the storage form, which is called glycogen. And there's very limited capacity in the liver to store glycogen. If there's still excess glucose, then the liver changes the glucose to fat. And the fat, the name for the fat is triglycerides. And we can get an increased level of triglycerides in our blood, but also fat is deposited inside the organs in our abdomen and around the organs. And what happens, we see when we put on weight, is that our waistline extends, as you can see in the picture. But this high carb diet leads to a condition called insulin resistance. So how does that work? These high carbohydrates, sugar processed food, leads to the high insulin levels, as we've seen. And in time, and this can take years or decades, our cells and our organs become resistant to the effect of insulin, meaning that insulin can't take the glucose into our cells any longer for energy. So our cells and our organs become energy deficient. So insulin resistance is the underlying metabolic condition that leads to many lifestyle diseases. But it's also a blind spot because it's usually not diagnosed. It's pretty much like an iceberg where you can only see the top of the iceberg, but in reality, it's much bigger. And that's the section that we're completely unaware of. We can see here through the age of a person from 0 to 70 years, for most of the time, most people are really unaware that they're insulin resistant because the red dotted line above that is where symptoms appear of lifestyle diseases. But we could have been insulin resistant for decades before the symptoms appear. We need to increase the awareness of both doctors and patients to identify insulin resistance. So we need to bring that red line right down to the bottom so that we can diagnose it, but also treat and do something about it, because it's not a condition that we can treat with tablets or medication. It's a condition that we can treat by changing our diet. What are the secondary diseases of insulin resistance? Let's start on the right-hand side. If our muscles become insulin resistant, we call it type 2 diabetes. In our heart, we develop high blood pressure. If it affects our reproductive organs, we become infertile. And that's for both men and women. And it's the most common cause of infertility. In the liver, we see fatty changes similar to alcohol changes. We get a lot of fat in our abdominal area. In our joints, we can develop arthritis. And did you know that the most common cancers like breast cancer, colon cancer, and prostate cancer have an underlying high insulin level? And then if our brain becomes insulin resistant, we call it Alzheimer's disease. And many scientists also call Alzheimer's disease type 3 diabetes. In fact, 80% of people with Alzheimer's disease also have type 2 diabetes. So in summary then, fat and cholesterol are vital substances required for many different functions in the body. And this is the one aspect that the proponents of the fat, cholesterol, and heart theory cannot explain. They cannot explain how fat and cholesterol can be bad for us and that they are vital substances at the same time. Cholesterol can be changed by sugar to form small dense particles, and that's linked to an increased risk for heart disease. We also know that the human body has no essential requirement to ingest exogenous carbohydrates. Yet, our modern man-made foods, and these are all the processed foods and drinks in the supermarket, have a very high carbohydrate content. If we follow a high-carb diet, that's the SAD diet or the standard American diet, it leads to high insulin levels, which in turn leads to the condition insulin resistance, and that ultimately leads to one or more of the lifestyle diseases. So what should we eat? And I borrowed this slide from the Noakes Foundation in Cape Town. Let's look inside the triangle. We need to eat high-fat dairy. We need to eat whole food. We need to eat eggs, poultry, meat, seafood, good quality protein. Sugar is high in fruit, so we prefer to eat low-carb fruits such as berries. Keep away from the starchy vegetables, preferably eat the green vegetables, and completely avoid processed food like bread, pasta, sugar, corn products, beans, rice. With regard to milk, if you're not lactose intolerant, perfectly fine to use it. Always use full cream products. Just remember that milk has also got some carbohydrates. And now what is very important is for us to understand and ask the question, am I insulin resistant? And the easiest thing to do is to take a tape measure and measure your waistline and also your height. And then you take the reading of your waistline and divide it by your height. And the value should be less than 0.5. If it's greater than 0.5, it's possible that you are insulin resistant. Ask yourself, do you eat processed food or refined food? Do you drink fruit juice or fizzy drinks? Do you suffer from high blood pressure? Do you suffer from anxiety, mood swings, or depression? What's your fasting insulin and glucose levels? Usually doctors don't test for insulin, but it's a much more sensitive marker than glucose for insulin resistance. Do you have high triglycerides in your blood and maybe small dense LDL cholesterol particles? Do you have skin changes like dark discoloration in the skin folds, or maybe skin tags under your arms and your neck, under your breast? You suffer from sensitive teeth and gums. You suffer from heartburn, and so the list can go on and on. And this is my last slide, and it's really to say that if we have more knowledge about what is the correct type of food for our body, then we can make changes. We can change our diet, and we can change the way that we're thinking about food. If we don't do that, and we carry on with the standard nutritional advice, in a great percentage of people, it will lead to insulin resistance and one or more of the lifestyle diseases. Now, I really enjoyed sharing this information with you. If you're interested to read more, there's a lot of information on our website. You may also be interested to know that we've written 3 books, 2 recipe books, and in the middle, Eat Well or Die Slowly gives more medical information and scientific information about the background of metabolic diseases and how it impacts our health. There will also be a link available to you if you want to download a free chapter from this book. Thank you.